Welcome everyone, and welcome to pattern matching. So that's what we're going to be talking today is about pattern matching feature that was released in Python 3.10 last year around October. It was released. So here you can find the slides. Actually, I made a thread explaining what we're going to be explaining today, so you can also go there and check it out. I will also add it in the end of the slides. So let's start. A little bit about me, if you are yesterday taking notes, maybe it's repeated, but yeah, I really like Python, and I organize PyLadies Munich. I also work at Aiven, where we manage open source database for you. Also, we are a Python company. In case you want to apply, feel free to talk with me after this talk. Yeah, let's start. So, how this talk will be structured? We're going to go over a little bit what was in Python 3.10, and for social media, we're going to learn about Python 3.10, and I will talk specifically about pattern matching. Going to go over some of scenarios that you should use pattern matching, and I will give you my final thoughts. When I have a heart close to the code, because I have some snippet code, it means that I'm using pattern matching, so you can take a look that maybe it's easier to understand. So, in the release for the Python 3.10, there was a party. Actually, Python 3.11 was also released 2 weeks ago, and they also did a party. So it has become a kind of tradition to release Python and make a party. So how does it work? They meet online with the Python core developers, and then they talk about the features that they added. They also talk about how was the release process, whatever went wrong, or what was nice. This is quite nice because Python is such a big language in terms of code. So if something goes wrong with that release, it's a problem. So they also show how the testing works, and that the release process starts with RC and so on and so forth. That you can pre-test Python 3.10 even before the stable release is done. And here's Pablo Galindo. He was the release manager of Python 3.10, and he's also the release manager of Python 3.11. So, at the time of Python 3.10, when Python 3.10 started to be used, it was a 2-digital minor version. So, people would have to go from Python 3.9.7 to Python 3.10. You can think that some stuff may break with this change. That's why it's important before you just jump in the stable version to test whatever with the beta version, RC, and so on, so you can avoid some breaking chains. One thing that was added in Python 3.10 was the meaningful messages. So it was like better error messages at the time. And in Python 3.11, they call even better error messages. I'm not sure how they will call in the next Python, but even better, something like this. So what are those meaningful messages? When you are working with Python in the previous versions, it was not so easy to understand where was the error. From Python 3.10, you can really see the difference that it tells exactly what it is. Sometimes it gives you suggestions, and this was only possible because Pablo Galindo and his team, they work automating the way the messages were done. And people really like it. I think it's good for, especially if you are starting in a language, that you stick on that language, because if you start and you get so many errors, and it's always you have to go and try to find the answers outside, it could be stressful. So I think this is good. So next is, this was really, I think a week ago, I looked in PyLadies, which has the 360 most downloaded packages on PyPy, if they add support for Python 3.10. You see that as already 62.8% from last week. I got this data. So a lot of packages, they do support Python 3.10 already. But this number actually can be even higher than what is here, because it's this when they explicitly support, they need to put a tag or something like this, that PyLadies knows that is explicit support. So it could be that it's implicitly support as well. There was even a discussion about this online. If you are using MyPy, from this version, MyPy 0.940, it already supports Python 3.10 with the match statement. What does that mean? When you are running MyPy and you have a match case there, it will check if there is exhaustion of all the options. If you don't know this yet, you will learn what pattern match is, and this will make sense. So you can use MyPy on that. This talk is based on those PEPs. So there was a PEP for tutorial, there was a PEP for the specification, and there was a PEP talking about structural pattern matching. You can find everything here. It was really quite a big feature, so they had all these tutorials there very well explained. So what was new in Python 3.10? It's a bit fun because we are now in Python 3.11, but you will know what was new there. So with Python 3.10, Pablo Galindo, he asked in the online which kind of feature people like from this version, Python 3.10. And he put as an option pattern matching, better error messages. There was also context manager that was added, some different way of dealing with context manager, and type union operator. People seem to like more better error messages, but the second place goes to pattern matching. Because, so today we're going to talk about pattern matching. I'm sure better error message will give a great talk, but I choose pattern matching. So what is pattern matching? In computer science, there are different ways of thinking about pattern matching or even matching. So, but in Python, in this feature, when we talk about this feature, you have to keep in mind that it will or it will not be a match. It's different from dating applications because you can have so many matches there, and in the end, you don't have any real life match. And it's also different from pattern recognition because when you have, for example, an image of a cat and you want to check, okay, is this a cat? You have some sort of three shoulders, check, okay, maybe if it's 90% similar to what a cat looks like, it is a cat. So it is not really exact. But in pattern matching, in Python, we will think it will or it will not be a match. Did we have pattern match before? Yes, we had primitive pattern matching already. For example, when you make assignments with x, y equals to 1, 2, Python is smart enough to know that x is referring to 1, y is referring to 2. You can also think, is there something else that you think that looks like a pattern match in Python before the match statement? If you think in your mind, you may find the try and except. It was a little bit already what pattern matching is. You have a try, and you can have several exceptions, and if one of those exceptions is catch, or you would go there. So you would try something, and otherwise you would go to the exceptions and try to find one there. This was some sort of primitive pattern matching. But moving forward, how can I explain pattern matching to you? So back at the time, I was interviewing people from my company, and a lot of my coworkers were always asking if the people who are being interviewed, if they like to play video game or some sort of games. So it was quite important, I guess. I don't know. I did play, and I was not so sure why they want a game body as a coworker as well. But I will use some sort of a video game or game for you to understand. But I'll pick a very easy one, which I don't know the name in Polish. But how does this work? This game works. It's for kids, so I hope everybody can understand. But there's like, for example, you try to take one of this and try to match in the different forms here. And it should only enter in the right format, okay? So I think this is a great game. I should buy it and present in real life. But so here's like just an example. If you have here, you make declare string 4, and it's a triangle, and you're gonna try to match with the 4, and you go case by case until it finds a triangle and it brings. So it's really straightforward. Well, when you are looking at the tutorial, you will see there are some words there that are relevant, and I'll explain to you what do they mean. So the pattern is each one of the case, which have after the case, you have the pattern. And the subject is what you're gonna compare to each of the pattern. And in the end, we have also the word called wildcard that is kind of if it didn't match with any of this, it's kind of a else. It will be, even in some other language, I think in Scala, they call this like else. But yeah, we call it as wildcards. And this is underline. So just to you know, if you are inside a pattern matching code like this, and you have an underline, the Python will understand that here will mean a wildcard. But yeah, moving forward. So this is how the pattern matching would look like. So you have a match with a subject, and you go over the cases. You try to see if the first case is correct, and if it's not, you continue until you exhaust all your options. You may be thinking what you should not do. So the way you think about pattern matching, like just logically, you wouldn't put the broadest case in the beginning. Because what does would mean? It would mean that you are open this game and everything could come in. Because if you have more options like combinations, it does not make sense. And it does not make sense so much that even if you try to put the wildcard, for example, in the beginning, it doesn't work. The compiler will say you are trying to catch whatever right in the beginning. So yeah. This was just like, the way you think about pattern match, you think a little bit like in a triangle. You go from the most specific case until you reach the broad ones, when you are organizing. It's very cold here. I may do like, yeah, so here's like some code with and without it. I hope it's enough to see. So what we have it here in the first one, we have a function that receives a list, and we're gonna pattern matching with on that list. So elements is the list. And if you go to the first one, you have, is this a list of one element? And then it checks. If it's a list of 2 elements, this one is interesting because I have here object has a variable, and what it's doing is binding whatever is in the second option or in the second position to this variable called object. And from there you can reuse in the statements. And it's really called binding, it's not called assigning when you talk about pattern matching. But yeah, it's useful. And then I have here a wildcard. If you try to do the same code with if and elif and else, is possible. Because yeah, whatever you have has if else, you can try to use pattern matching there. But yeah, so here with if, else, you would have something like this. But so do you see, in the second case that we are looking, we would have to check if this list is made of 2 elements, and we would have to check if the first element in this list is a triangle. So we have to write more code to do this. And when we write more code, the possibility is that we're going to make a mistake. And we also have to access those, the second element and put in a variable that we want to use, for example. So in the end, I would say that with match case here, it looks better and is much easier to understand. You would see, like, just looking at the code, you would understand. I'm talking about a list of 1, 2 elements, etc. I took a look about the timing when I use pattern matching, when I don't use it, to see which one is faster. So I did saw that this one that I just used an element of a list of 3 elements, both were quite the same. But I went forward and I tried to exhaust the list, exhaust all the options, the pattern matching, and I see that with pattern matching, it was faster. But I cannot tell you that it's just because you are using pattern matching. It could be because Python 3.10 was already a bit faster than the previous ones. But I saw that it was fast. And Python 3.11 is supposed to be even faster. Maybe I should do the same with this one. So here's another scenario that you can use pattern matching. When you are matching for example, you are matching a number that is an integer. And without pattern matching, you could do number is equal to something, and so on and so forth until you find it. With pattern matching, you would just basically put which value you are trying to match there. I found it better with equals explicitly, because in Python it has a saying that better explicitly than implicitly. And as pattern matching is still quite new, I would still do this way with the if else, because it's just like, you can see that's actually comparing numbers is equal to 0. So it's much easier. So there is something called the guard in pattern matching. What does the guard mean? So this basically means that inside the matching you can do a conditional. So you see that pattern matching in Python, it is much more powerful than in other languages, because it came so late in the language that they took inspiration from different languages to bring it there. And one thing that you can do when you are doing the guard of pattern matching is to use a conditional. So for example, here you would say, okay, does this list match with a list of 2 elements, and if this element is in exist. So actually you can bind whatever was there, and you can reuse in your conditional. So that's pretty much what pattern matching means. And there's another thing called composable pattern with you can do with this element. I will move very fast because it's so slow to move the slides, but I will show you now. So yeah, consider, for example, in this game you have 4 directions. You have the top, the bottom, the right, and the left. And you want to check, what composable pattern is when you have a pattern inside a pattern. You can bring more patterns inside the pattern, inside the pattern, inside the pattern. It's a bit like a matryoshka kind of doll. So you could make very complex things with pattern matching, and this is start to become more interesting. So you have it here, a list, and the first element you want that matches with direction, and the second element you want to match with more things. So it could be even bottom, top, left, or right. So it's already you are having another pattern inside this pattern. And you bind, for example, in this example, I'm binding to a variable called side and checking whatever I want to do with this. But yeah, this is the idea of composable pattern. You can also match with objects. So this is also cool. You have an object there, you don't, and yeah, for example here, you would think that what you are doing here is instantiate an object, which is not true. What you are doing there is making a match on that object of a circle. And what is nice about this is that you don't need to specify all the attributes. You can just specify the attribute that you want to check. So imagine if you have a class that has like hundreds of attributes. And it's really cool that you can just pick one that it matters, right? So this is something very nice about pattern matching. It's just really clever. Another cool thing, if you are working with JSON, if you are working for web development, probably you are working with some dictionaries, with JSONs in Python that become big dictionaries. And you know, dictionaries has also like those nested ways of organizing things. And one cool thing with Python 3.10 is that you can match on that dictionaries. And again, similar to what objects with attributes does, here you don't need to match all the key values. So if you want to do this with if and else, yeah, probably you would have to match everything else, something like this. But with pattern matching, you just pick the keys that you want to check, and then you match. So that's something interesting. I took here a question from Stack Overflow that the person wants. So you see that it's a bit more advanced question, but what the person had a list of dictionaries, and the person wanted to check if I could match all the dictionaries who have ID has starting with match me. So in this case, match me who would be okay, should match me bar should match, another ID should not match. So what you will see, that yes, you can do this. So how can you do this? You would combine, for example, you could use here the guard that we saw, and you could make a conditional out of this. So I say, is it in the case ID X, when X starts with match me, and then you could do something else. So you see that is really powerful the way you can reuse of other stuff from Python. I had questions when I was this was even the RC release, so some really time ago, I think a year ago, I think. What was this happened? So I had a dictionary, and I tried to match this dictionary with an empty dictionary, and it matched. It's very unexpected for me, because I don't have an empty dictionary, I have a dictionary with a key. But I tried to do this with a tuple, and a tuple had elements, and I tried to match it with an empty tuple, and it does not work. So what I mean it doesn't work, it does not match with anything, so it returns none. So what you can see here is that the way they design this matching with dictionaries and with object instance is that first, what it does, it checks if it's an instance of. This is the first thing. So in this case, this dictionary here is not checked for the key and value in the beginning. It's just checked, is it a dictionary? So that's what it's doing. And yes, it's a dictionary, so it will match. With other things like tuple, list, and so on, it won't work like this. It's just the way it was designed. But it could be confusing, I believe. So some final thoughts on this is, yeah, some people, every time that there is a kind of new feature or a new thing like this, people have opinions. They have strong opinions. Some people don't like. It was the same with the words operator. Some people didn't like, some people like. Yes, I would say that pattern matching is a powerful feature. If you can use correct, it will help you to understand your code in the future. But of course, it's whatever works for you. If you are more comfortable with anything else, you can continue. That would be my final thoughts on that. So thank you. You can find this thread, which explains kind of the stuff that I say in a more detailed way, and with the slides too. Thank you. So check if there are questions. Yeah, if you want to ask a question.
I can talk.
No. It doesn't work like that.
I'm so cold. I need to go get my jacket. I'm freezing. It was not because I was nervous. I was really cold.
This wildcard, in those examples, you were mostly using it as like this catch-all at the end, but yes. You're also aware that it can be used like, for example, this dictionary to say that it has a key, but with any value that's there. That's also like one quite use case for it.
You can use the wildcard with the dictionary as well. Like, imagine if you had a lot of keys that you check, and in the end, okay, nothing match, you could use the wildcard.
Yeah, but it's more like you could put it inside of the dictionary as the value for a key you can do. I just tested it.
Can you do this?
Yes, you can.
Okay.
So it's like checking that dictionary has this key of whatever value, and you can use it for.
You cannot
you cannot use it as a key though, which is sad.
You cannot bind the wildcard. I think I
maybe not binding, but I wasn't familiar with binding, so maybe it's doing the same thing.
Yeah, but it's only a placeholder for anything.
Yeah.
Yeah, but you cannot bind and reuse inside. That's for sure.
Sure, but if you just want to check that there is something there, but you don't care about what this something is.
Okay. It's
like the example with your empty
disposable,
dictionary.
right?
The empty dictionary, or even this like list of value. If value, you can just say it has this value and any number of wildcards, or there's 2 wildcards in front, some value that you want 2 wildcards behind that you can also do.
Yeah.
So this is something to look into for
but this
future version of the slide.
wildcard in this case, so it's just getting rid of the variable.
Yeah, but it still matches it.
It could be better.
Like if you're wanting to have a matching of a list of 5 items, where the middle item is 5. And you would use wildcard for this scenario, so it's something.
I will have to see the code, to be honest. You just tell me, I don't see it. If you show me, I will.
I can test it later if you want.
But
Anyone else?
Okay. Any more questions? I think that's all. So thank you for giving an extra talk for our conference.